All right, we are back for Advent of Code 2024, day 4. We're starting about 25 minutes, and I think that's enough time for for a warm up. We can revisit day 3 yesterday. So, day 3, what was it? Let me just bring up the input. We had this input, and it looks like it could be fancier than what it is, but what it really is it's hiding a few statements, and everything else is garbage. So it's these mul statements, multiply these two, and there are do and don't statements, which enable adding the result of those products. Okay. My instinct with things like this that could be regexes is always to avoid said regex. So that's what I did. I did a hand rolled parser here using these reverse interpolators to extract these various values. The problem with stringing these together, so we have a parse mul, that's straightforward enough. But we have the parse do's and we have the parse don'ts. And the problem we get to is now, if we're going to parse one or the other of these, well, it could be any of the three. So we have to know which of the three we're parsing. And when we're parsing these muls, the way I have this set up is that I don't really know the index of this because I don't know what the this that I'm looking for really is. And I think it should just be easier to do as parse the next of either will do or don't. So I don't have to do that to either logic myself. We'll just put it in the regex engine. So let's start by writing some regexes. Actually, let's start by handling whatever these issues are here. Are there issues in here? It's showing up as red, but I think those problems are really just warnings, which I do need to fix that in my build. We'll get there eventually. I'm happy with this potentially failing. Okay, so let's have a test string. Val test. We have a bunch of garbage. Roll two numbers separated by a comma, and a bunch more garbage. And some of that garbage could itself be a mul. And I guess there could be other paren stuff. But the goal here is to get mul 2345 out of there. Okay, and you know what? Autocomplete does this for me. Okay, escaped parens, great. We have the comma, and then we have two capture groups. Cool. One for each digit region. Okay. And now we have, okay, with Copilot, this is just too easy. I don't have to remember anything. Okay, great. So we can use this directly as an extractor. We could also use this in a pattern match. So this is as if we were doing this in a pattern match, but we're assigning the values A and B. I wonder if there's a way to compose multiple regexes. Yeah, let's see. Do regex. Val, don't regex. Okay, and then val, we have an instruction. regex. Um, can I not just compose them? I guess, yeah, just pasting them in. I would kind of like to compose their strings. So like mul regex dot, is it pattern? What's its value pattern? It's a Java pattern. I'm not sure. We can get to that later. First, let's just test this out real quick. So test, or rather, val mul regex AB. We can extract from our test. And then we have A and B. Of course, this is refutable, so it gives me a warning, but it should assign values to A and B. We have, oh, right, we have multiple parse moles. Let's just comment this out for now. And this is failing because there's no dot star at the start. Yeah, that should be necessary. So let's change this definition. Dot star mole followed by dot star. Well, let's just see what that there is. There we go. Okay. And then we'll turn those into ints. So now let's do this instruction regex. I really wish I could just let me see if there's a way to compose regexes. Let's ask ChatGPT. Okay, is there a way to compose multiple regex into a larger one? So combine them with the bar. Okay, dot regex and then dot r. Okay, so let's try that. I don't know, I'll just say the left one because that's the one I actually read. Okay, so inst regex. What can we do? Let's do dot star. And then now we have regex dot regex. Is that valid syntax? Do I have to have an S here? Okay. Cool, cool, cool. And yeah, let's just try that in our test pattern. Oh, wait, why are there three? That doesn't make sense. Okay. We have inst, and I guess this does form a capture group. Okay, well, what will that inst be? Okay, we can't do the pattern batch, pattern binding that way. Wait, what's the actual error? Yeah, it just says that doesn't match. Uh, okay, let's do a simpler test. We'll keep the original, but let's say, oh, this mul regex already has a dot star. Let's just do a do regex. Do regex. Okay, val do regex equals, or no, let's try our do regex. We'll just call it foo equals some garbage to some more garbage. Okay. Yes, of course that fails, but if we did the inst regex rather, we should extract the do. Okay, yeah, we extract the do string. I'm gonna comment this out, and we'll take the dot star out of here. So it's just a mul. And yeah, I guess I don't know how it works if you combine the mul regex, which can extract two values, with a do, which can extract one. But we can at least do or don't. Oh, and I didn't do dot regex here, as the ChatGPT had said. What does dot regex do anyway? Dot regex string. Okay, right. It gives us a string value. So I guess we have to do that. But also we don't. I guess it automatically two strings that. Let's do regex at two string. Yeah, I suppose it already does that. Okay. Let's just put a don't for this and see if it catches that. Hey there. Hello, hello. How are you? So, I'm doing what you did yesterday after your problem solving. So I'm taking day 3 and I'm gonna rewrite it with regexes. And I've got my regexes, my individual ones, and I'm trying to do a composition. So in Scala, there's this kind of nice extractor syntax. So I could take my mul regex, for example, and I could do val mul regex a b equals mul 3445, and that will assign the string 34 to a and 45 to b. And I can also compose regexes this way. So this here is a regex that's either do or don't. Oh, hey, Blue, Marcus, good morning. Welcome, welcome. So I'm taking my day 3 and I'm turning it into a regex solution. And as I was saying, when you define a regex, you can use it as an extractor here. So you can use it as an extractor in like a val definition, or you can use it in a pattern match. And so I have 3 individual regexes and I'm composing them. So here's an example of composing a do and don't. And now what I'm not sure of is what happens when you compose do, don't, and mul, because the mul extracts 2 values. It has 2 different capture groups. Um, and honestly, the do and don't even really need capture groups. I suppose with the mole, I could remove the capture groups altogether. Mm, yeah. And then just give me like the whole mole string. Because if you have an example like this, we'll just full screen. Um, so this should capture a do or do. Oh no, it's capturing the do. The regex it's using is do or don't. Oh, there's no don't yet. I have to put an apostrophe. So now that should capture don't. Value of foo should be don't. Yeah, that's the thing. You never know when they're gonna ramp it up, do you? They ought to ramp it up, and I feel like there's enough variation. It's hard to know how a person, like an individual person, will react to something. Like today, it might feel ramped up for me. Tomorrow might feel easy, and it could be vice versa for someone else. But I do hope for a little bit of a ramp up. Um, yeah, okay, how do I compose this? I mean, I could just use these individually. I really could. Um, that's not what I want to do. The point's to make this nice. Could be 15-minute or 15-hour. Yeah. I felt that about day two or part two. If you're doing a one pass, it could be a little bit longer. But if you just do it as a brute force, it's like a 2-minute problem. Okay, why is foo binding to do? There's a don't right here, right? Okay, what if I remove that do? It binds to a don't. Ah, okay. Well, that's not great. But, okay, it's basically going to try and bind do, and if it can't bind do, it binds don't. But I want to bind the first that appears, not just. Hmm. I'm not sure how. I would have thought that that my intuition would have told me that the first in that group is what gets bound, but that is not the case. All right. Good luck. We'll see you on the other side. On the other side, you have many meetings today. I think go for an easy one. That's fair. That's fair enough. Yeah, I want an easy one on Friday because that's when all the lack of sleep will have accumulated. I mean, I guess Friday I get to sleep in. Maybe Thursday. Friday can be hard. Oh, but I'll be drinking Friday night. I'll have at least one drink. It's my birthday at midnight, so do you have to go out with people? Be social for a bit. All right. Um okay, so clearly it just binds the first that matches anywhere. I have to ask GPT or Copilot about this. So let me see. What am I writing to Copilot? I had anticipated that a group with multiple alternatives bind to the earliest pattern to appear, but it just binds the first pattern that matches at all matter where it is in the string. How do I make sure it binds to the earliest? Yeah, I know you guys can't see that. Okay, by default, there's a greedy fashion. To do the earliest, we need an anchor pattern. Start from the very beginning of the string. Sure, I'm not starting from the very beginning of the string though. Non-greedy quantifiers. No. This dot star. I mean, I guess I could just keep dropping the first character and then try the regex until the regex works, and I could remove this dot star. Spending more time thinking about this than I expected to. You could order the alternatives thoughtfully. You can use look ahead. Or you could find all the matches and sort by start position. Honestly, that's kind of smart. Yeah, just find all the matches in a string and then sort. Cool. Yeah, I think that might be the approach I go with. We're out of time, but I'll at least define. Let's define my composed regex. Do, don't, and we have our mole. And our mole we're changing. We're going to remove the capture groups. And there's my bell. We have 2 minutes to start. Okay. So I've got to wrap this up. This here shouldn't work anymore. It should just be the mole string. Oh, that's not a capture group. This here is a capture group, and this here is a capture group. Okay. We can work on that later. So we have our day 4 problem. Error bounce. Yes, good luck to you too. Marcus, yesterday I watched a programmer who's in the game for many years, absolutely struggling with regex. Yeah, I think it's good to get good at that stuff. I want to do like a little mini course where I just go through a lot of practice problems and feel really comfortable with it. Yeah, to do it the first time around, it would feel good to be a master. Like I've seen, and you know what? I think it'd be fun to watch someone who is just really good at crafting regexes, just spontaneously on the spot without having to test them. uh, it's like watching an Apple programmer, APL programmer. I've seen a few of those streaming every now and then, and it's crazy to watch. You redid your code with regex? Yeah, I'll do that too. Probably after I finish this problem, I'll go back to that and try to make it nice. Okay, 30 seconds. Mm. Oh, yes, yes, totally. All right. Well, 10 seconds. Good luck, everyone. Let's see the problem. Series search. Oh, uh, Christmas. Xmas, Xmas, Xmas. All right. Oh, no. Okay, it's a word search, which is fine if I'm on a computer. If I actually had to do a word search, I'd hate it. I've never been good at those visually. Um, all right. You have to find only one word. Xmas. You search anywhere. Um, it's full of letters. To, occurs to, okay, how many times does Xmas appear? Ah, this is easy enough. So we just do the same thing in multiple directions. Def count Xmas. So this will be like mostly grid manipulation, turning it into other grids um, through which you can search. Okay, count Xmas. And whoops. Oh, no, that's not what we want. String dot. Contain. Why am I blanking? Index of string. Yeah, we can do that repeatedly. And then iterate. So we'll do this. Iterator.iterate. Isn't there a all occurrences s dot last index of find no. Okay, whatever. We can handcraft this very quickly. Iterator.iterate. And so index of can have a start value. Right. So x index of Xmas at this index. So index plus 1. And I guess we start at -1. And then we search from index plus 1. And then I guess we take, well, not -1. Oh my god, why am I handling this? So occurrences drop the first one because that's going to be a -1. And then we take, well, not -1, that size. Okay. Let's test that real quick. ALU, Xmas, ALU, that should be 1. That should be 2. There we go. Okay. Hand rolled. No. You leave it at that. Okay, and then now there's a forward search. We'll just name them by direction. So right occurrences equals. So get lines that to list. And we get a list of strings, right? Okay, val left equals input dot map dot Okay. And then up, down, input transpose. Okay, now we get to the diagonals. And for the diagonals, we can shift. Okay, we could shift each line forward by 1. Or we could shift each line kind of vertically. That might be easier. So let's say you just, let's say you have the horizontal line, right? And you just shift each column down 1. So the first line would be the first line of the first line. The second line would be the second line of the first line with the first line of the second line. Okay. So val shifted equals input. So each line in the first will sort of get. Man, I've done this before in Project Euler a few times, and I can't quite remember the nice way to do it. Let's just pad everything. That's the fastest way. So val, let's take input zip with index. We're not doing a for each. Doing dot map case si, and then let's just do a space. Yeah, space times I plus s. And then let's add space afterwards. Plus, yeah, exactly that. Okay, yeah, that's just everything over. And this one we can search up and down. So that'd be, yeah, that's good. So shifted dot transpose. I don't even know what direction that is. Shifted dot transpose dot map reverse count. Oh. I guess we have to do a map make string after the transpose. And I guess suppose this could have just been make string dot reverse. Needless refactor right there. And we do the same thing here. Oh, great. Good job. Good job. I have 2 more cases. So I got the diagonal by shifting, and that lets me get. Now I just shift in the other direction. So I'll call this shifted right. And then now shifted left. And then Autocomplete, autocomplete. Knows what to do. And now val as 1 equals, oh, we have to give these names. I don't know what direction this is, but I'll call it right up. No, right down. Val left up, val left down. No. It's a sum plus all the others. Okay, there we go. There we go. 2, 3, 4, 4. Okay, there we go. There we go. Well, I'm still top 2,000. I could have been top 1,000. It took me too long to do this bit here. I was trying to overthink making it nice. Okay, part 2. Chris, thank you, thank you. So, did you misunderstand the assignment? Classic admin code. It's an X-mus puzzle. Oh. Find 2 MAS in the shape of an X. Within the X, each MAS can be written forwards or backwards. Okay. So now we don't have to worry about. Okay. I can subdivide this pretty easily into smaller grids of 9, and then just check if they match any patterns, and I can count that. Count how many patterns they match. Yeah. Other solutions. I could also just search along the diagonals again and count the masses. Oh, no. You have to search both diagonals at the same time. Okay, so I think subgrids are best. Okay, let's make a grid. Okay, a grid of vectors, and we got import area endpoint. Import AOC dot area point. So the area that grid. I'll set the areas. Okay. 0 until grid dot size -3. -3. Yield. No, yield a new area. There's no. What are those points? Okay. And then let's just check sub areas map size. Oh, area bounding for those points. Okay, too big, too big. It should be +2. Okay, and off by ones until grid dot size -3. Is -2 sufficient? Yeah, it's actually -2. Jeez, off by ones. I've gotta make a better way to write that. I don't want to be making off by one errors. Okay, okay, so we count Xmas. So this is in an area. Okay, let's just start with this. If, what's the middle? Sub area dot top left dot down dot right is not equal to A, or rather this point applied to our input. So if grid is not equal to A, then we have 0 instantly. Otherwise, yeah, we're just doing ifs. Just do ifs. So top left is equal to M and bot left. Or bot right. And it's not an else if, it's basically an or. And we count those. Yeah, just make a list of these. Dot count. And it's just Boolean identity. How many of these conditions are true? Okay, yeah, almost had it. So this is M and S. Grid. So bottom left to top right. And then bottom right to top left. Okay, okay. Top right, bottom left. All right. Oh, it's bot left. Okay, now we take sub areas dot flat map count xmas dot sum. Overloaded. Diagonal. Okay, let's rename it so we don't have to worry about overloading. Sub areas sake of area, this should return an int, right? Required. Oh, wait, why am I flat mapping? Just map. There we go. 5312. Okay. 5312. But I feel like we have the right idea. Okay, let's look at a sub area. Sub area 0. S dot top left. S dot bot right. 0, 0, and 2, 2. Oh, hold on. Grid dot size isn't quite going to be right. Oh, this is too many. Grid dot x range. I should have that. Oh, let's do this area. Area dot x range dot last -2. Area dot y range dot last -2. That's a lot of sub areas. What's the area? Area dot width. Okay, 140 times 140 is that. And 138 times 138. Okay, so we're not quite correct here. Area dot x range at last. 139. Well, there's nothing at 140. No, there is something at 140. So 148 should be the very last xy. Just gonna make this width -2 and height -2. There we go. Okay, so now our sub areas are correct. Does that change? That shouldn't change our answer, actually. Just the way we structured this. Grid apply to a point. Okay, so we're searching 19,000 subgrids. We should test this on a particular subgrid. MAS right here at 1, 1. Sub areas, you know what? I think I can index right into this 142. 1, 2, 3. X range 4 to 6. Okay, sub area 139. Now let's count. There should be, looking at this grid, MAS, SAM. There should be 2. So count Xmas diagonal. There should be 2. Hey, okay, so it works for that. What are we missing? For the very first one, it should just be 0, right? So if we did this for 0, yeah, it should be 0. It should always be 0, 1, or 2. Is there a chance for double counting any of them? No, because each subgrid is non-overlapping. They all rely on a different centerpiece. I just tried 5312, right? I'm still getting 5312. I feel like I'm so close. But I need to debug. It felt good to write this code. Top left, bot right, top right, bot left, top right, bot right, top left. I am not sure. I'm going to run this on the example. And then if that doesn't work, I need to write my own edge cases. I'm going to take 4. In this example, Xmas appears 9 times, and I show them all. Okay, so let's return to the X. That should appear 9 times. These don't exist anymore. 18. Oh, am I just off? I am double counting some. So this is 5312 divided by 2. 312. 2656. 2656. That's our bug. No? I did just type in 2656, right? Okay. Okay. So we are double counting. How are we double counting? Let's check our sub areas. That size, and then that distinct, that size. 64. Should there be 64? Okay, let's count this manually. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Oh, okay, I'm missing. You have to find 2 of them in the shape of an X, not just 1. Oh, okay, that's where it is. Great, great, great. So This is just wrong. Not completely wrong though. So we just pair any of these two. So either this top left and okay, I'm gonna do the quick and dirty thing here. I think I've got mine. I just have to um so top left bot right, top right bot left. It's always the same pattern. And now we just try S and M. Um, S and M for the bottom. Oh, I don't know why I'm copy pasting. I'm doing panic spaghetti. Okay. S and M. Okay, and this only counts as one. So else it's one of those four. So list dot exists identity. Yeah. And we can write that in a much nicer way, I'm sure. But we spent way too long trying to do it with regex before giving up and doing it the lazy way. um, wait, what's the lazy way? I don't think what I'm doing is lazy, except for the copy pasting right here. Um, okay, what happened here? Boolean required int. Shoot. If that, then one, else zero. Okay, that should work. We get 9. Perfect. Now we delete this x and our ends to 1815. 1815. Yes. Okay, got it. Got it. Okay, so I misread that for a while. I just thought, yeah, I thought you look for either of the diagonals. It has to be both at the same time. Mine's gonna be a lot shorter in just a second. Like this should be a 2-liner, if not one. How'd I do? Oh, I fell behind for that. Okay. Let's take out some of this test code. Okay. Top left, bot right, yada yada. I mean, we can just do this inside of the full comprehension. I feel like there's a nicer way. Let's see. By the way, I don't know where your repos are, but I think it'd be fun to do some code review at some point. If you have a day you're proud of, I'd like to take a look. Okay, we can do this in a full comprehension with just a S and M. What are there? 8 of these. Okay, for um, okay, so we have cross searches. Let's call this diags. Well, diags. Top left from M and A. Um, bottom right from A and M. Oh, those should be kind of zipped together. Oops. What did I just do? Okay, so top left, bottom right from MA, that's zip. Not MA, MS. Zip SM. They should always be opposite each other. And for top right and bottom left from MS zip SM, yield. I guess I'll call these the crosses. Crosses. And then now we do this. Yeah. So now if crosses exists identity 1L0. Okay, well that shortens that copy pasta. Should still get 1815. There should be a nicer way to express this search the sub areas. I hate doing this -2 +2. Oh, I mean, we could do this in terms of 2. 2 -3. Or honestly, since it doesn't matter that it doesn't actually matter that we got a bound. Yeah, so a dot x range. Oh, it does matter that we go out of bound. Never mind. Okay. If I say last, wait, till. No, that was not my answer. It was 1815. If we say that last, we have to do. I can't math this. -1? Why does that to be? What is dot last? Area dot x range dot last. And what is area dot x range? It's until 140. Oh, it doesn't include the 140. Yeah, so the last element. Why isn't it -2? I guess it would be 2 -2. This is okay. It feels more intuitive to think about it this way. That's fine. I'll accept it. I just hate thinking about magic index numbers. Oh, right. And this mess in part one, I could totally. Hmm. If I could iterate over the flips of a grid, like all the orientations of a grid, then I just make two grids, one and another that's shifted. And here, so if we reverse and then transpose, wait, will that work if we just reverse and then transpose? No, no. You just have to shift it in opposite directions. I don't know, certainly getting all the orientations of grid would work there. I think I'll wait for inspiration to make that nicer. But for now, this is welcome it for day 4. And let's go back to doing that regex for day 3. Um, day 4. Okay. How y'all doing, by the way? Let's check the leaderboard real quick. So a few people have finished. Oh, Harry Felton, I haven't seen in a while. Wait, which is this mine? This is my private leaderboard, yeah. I haven't seen Samarth around here in a while either. Not yet, fair enough. Okay, so 6 for part 1, and then I fell to 9th for part 2. Oh wow, look at this variation. Yeah, these numbers, these ranks aren't lining up very well. So part 1, well, I guess I'm the first one who drops a bit. Temper Alex also dropped a bit. I guess that means other people climbed a bit for part 2. Hey, I climbed a spot on the Scala leaderboard. Cool. All right. Back to day 3. So we have a mole regex. We've taken out the capture groups. Do and don't. And now we have this inst regex. And I guess what we decided to do is check if a string starts with a regex. And then we can just keep doing a find next. Let's make this explicit. Okay. Time is up. Need to debug later. Well, glad you finished part 1. You got it pretty fast, I think. You were definitely under. You're top 1,000, right? That feels good. I'll feel good any day I get top 1,000. All right. Well, good luck with all your meetings today. We won't need all these individual parse functions anymore. Yeah. See you tomorrow. Yes, remember hands one. There's a find prefix of. Interesting. At the beginning of the given character sequence, or none at fill. Hey, that's great. I suppose I shouldn't have deleted the parsemal. Def parsemal. And the almols. Okay, I can change the parsemal, but certainly we should keep the almols. And then we'll have some sort of a parsemal function. So this is assuming it matches. For now we'll do this. S.drop4. More. No, I mean, we can just do instRegEx, right? Let's just do this. What is the match? Do we need to do find prefix of? I'm not even sure what find prefix of does. Let's just double check that. Match this regex at the beginning. Okay. But I want to extract the match in the same statement. So let's do this. instRegEx next. And if it fails, let's do string.match. S match. Okay, so I mean, if it's empty, then we do none. We might not need that, but we can do instRegEx. and then inst match, and if it's a mole, we can extract the A and B. Let's start calling it X and Y like it isn't a problem. Y. Yeah, and then drop inst.size. Great, great, great. Case do, there we go. Case don't. And we just do this repeatedly. We can do this with an unfold. Iterator dot unfold. Initial state is our string. What's our string called? Yeah, just input.makeString, and we just use find next. That's already built for this. Great. Val instructions. Let's make that list. There's a match error. Oh, right. We need to do this recursively. So if there's none, then let's do it recursively. S.drop one. There we go. And is this here really necessary, this empty string? I don't think it is. I guess it is. Let's rewrite this a little bit. Let's say option dot when s dot non empty. And then we can do the s dot match, take this out. We can take these sum statements out. Oh, this is feeling good. Oh, and then this needs to be flattened. We can't exactly do dot get here, can we? Oh, we can? Yeah, I guess we can. Okay, and then now that we have all of the instructions, it's just this old code. And it's already a list. Okay, that's the answer we got, right? There we go. There we go. And there's like a part one to do still. Let's take out the test string. Oh, this is so much nicer. So much nicer. Okay, let's do a next mul function. F next mul. And now we can just do like find next. Find first in. Okay, what does that return? Okay, but we want first match in. Let's get the match. Find first match in S. And then now, what can we do with this match? So a match has, well, let's just explore it here. M dot end. So we can drop that. Let's do this val mul equals m dot matched. There we go, there we go. F all moles. Or we can just make that val all moles. Okay. Unfold with next mole. Unfold is so nice. Okay. Ah, this feels great. This feels great. And then all moles. No, what was part one? And then dot sum. Dot sum. Okay. This is nice. This feels good to read. It felt good to write. I'm happy with this. Mm. And we'll say refactor day 3 to use regex. All right. I'll push that up. And I think that's it for me for the night. Let's go find someone to raid. Pass this on. Is this end? Okay, let's search a tag admin of code. Oh, hey there, how's it going? I haven't seen you around in a while. I was just doing admin of code. So, I solved day 4, and I went back and solved day 3, or refactored it using regexes. So I'm kind of happy with how it turned out. So I just defined them individually. I took the match groups out of this. In fact, I might have a question for you there if you're good with regexes and Scala. But yeah, I took them out so I could compose them this way. And I defined these functions next mul and next int. And when they're defined this way, or next mul, next instruction, with the option string int, then finding all of them is just an iterator.unfold. So that felt nice. That means scale my instructions, iterator.unfold, and then I do this kind of fold left for the state machine, saying we're enabled or not. So I mean, maybe it's a little verbose, but it feels maintainable. Good to read, good to write. Uh, okay. You know what? Let's say hi to Zombie Cho again. I'm not sure. Is it Chow? I think I've been saying Shu. All right. So anyway, I'm finished for the night. So we're finding someone to raid. All right. Well, Arrow Bounce, Blue, Nafk. Good to see you all here. And I'll see you again tomorrow for more Advent of Code.